Solve the absolute value inequalities and express your answers in both interval notation and in set builder notation. Our first step is to isolate the absolute value bars. And in part A, we can do that by subtracting 3 from both sides. The 3's cancel on the left, and what remains is the absolute value of x minus 4, which is strictly less than -1. Once the absolute value bars are isolated, the next thing that we want to do is to double check to make sure that we have a positive constant on the other side of the inequality. And in this case, we do not. If we did have a positive constant, we would proceed by finding 2 inequalities that do not contain abs-vals that we can solve. But if we do not have a positive constant on the other side, as is the case in this example, then most of the time we have 2 possibilities. Either every x value is going to work, or no x values work. So we'll say it's basically all or nothing. So which of those scenarios do we have in this case? We could just start plugging x values in to see if they are all working or if none of them are working. But we could also just think about this. The output of an absolute value expression is always going to be a positive quantity. No matter what we plug in for x, once we subtract 4 and then take the absolute value, it yields a positive quantity. Now, a positive quantity is not going to be less than a negative quantity. And so this must be the situation where nothing works. So we'd say there's no solution. There is no x value that makes the output of this left-hand side, which is positive, less than a negative quantity. So how about here in part B? This is almost the exact same except for the fact that the inequality is going the other way. But again, we still want to start by subtracting 3 from both sides with the intention of isolating the absolute value bars. Now that we have our absolute value bars isolated, we see again that we have a negative constant on the other side. So since we don't have a positive constant, that's the scenario where the answer is either all or nothing. Everything works or nothing works. So let's think about this again. You could just start plugging in x values to see if the x values are working or if they're not working. But we could also think about it logically. The output of this left-hand side is always going to be positive no matter what we plug in for x, because the absolute value of that expression will always yield a positive output. And a positive number is always going to be greater than a negative number. This is always true. So this is the everything scenario. When we say that everything works, that means basically that all real numbers plugged in for x are going to make a true statement. And we can either say that we can plug any real number in for x, and a better way to say this is using set builder notation, which is the set of all x's such that x is an element of the real numbers. Or we can write this in interval notation, saying from -infinity to +infinity and not including either of those infinities.